good afternoon. Ready to start? Well, every day at 2 o'clock, you hear my voice punctually appearing. All right, let's continue. This morning, we should have talked about our Docker's layer management and Docker's image layer management. That is, what changes occur in our data when modified, right? Our layer management is set. Next, this afternoon, we will continue to discuss our network management, the network management inside our containers. All right, let's all learn together. Docker is just like our VMware virtual machines. Doesn't VMware have modes like bridged mode, host-only mode, and whatnot, NAT mode, and custom mode? Docker is the same. Docker also has 4 network modes. It also has bridge mode. It has host mode, null mode, and user-defined mode too. Very similar to VMware. By default, if you don't specify, it uses bridge mode, which is our bridged mode. Okay, bridge mode actually invokes the backend IP tables, creating a NAT rule. It performs an address translation. So by default, let's take a look together at our relationships between these cloud hosts. This BusyBox keeps failing to download. I don't know why. It's something we now need. If we don't have it, many of the software packages are not installed. Yes, it's not downloading. Let's just let it download. If it doesn't, then never mind. That's the default situation. Here, we have run 3 cloud hosts. I should have downloaded it last time. It should be there, not missing, definitely there. Just this morning, I had it shut down. I restored a snapshot over. There should be BusyBox. Okay, let's continue. Check out PSA. Look here, we have 3 cloud hosts. Actually, in our backend, we can see 3 IP tables rules. All right, let's take a look together. Here, by default, look at our firewall rules. There's a DNAT rule. DNAT means destination NAT transformation. All traffic to port 3306 is redirected to 172.17.03 port 3306. All from Ali's source, right? I'll try it. I'll switch to Ali's. Huawei Cloud isn't working today. I'll switch to Ali's because I need it later. Let me check. Image hosting container. Image hosting. Image accelerator. This one is from Ali. Let's replace the middle one with it. Replace it with Ali's. Okay. Docker. BusyBox. Look, its default root is right here. Wow. Lab. Under Docker. So, because you didn't specify here. If you had specified, wow. Look, it has come down. Finally, BusyBox has come down. BusyBox has come down. Okay. In that case, Docker, PSA Docker. We still do the same. Get rid of all these. Let's delete all these. Docker. Okay, before we proceed, let's take a look at our IP tables rules. Does it have any DNAT rules now? None. Look, are there any recent DNAT rules? None. Okay, let's write a rule. Docker run DP port 80, name web01, then HTTPD 2.4. Enter Docker PSA. You can see there is a rule here, accessing the host machine's port 80, redirected to our containers port 80. Okay, then let's take a look. Web01. This cloud host, you see its IP address is 172.0.2, 172.17.0.2. By default, once you've installed a container, your system will have an additional network card. Look called Docker 0. Its IP address is 172.1, 17.0.1. Actually, it is the gateway. Okay, then I'll draw a diagram. What should the current network architecture look like? It should be like this. This is our machine. This machine has 2 network cards. One network card called ENS33. Another network card is our Docker 0. Another network card is our Docker 0. Moving down. This then is our host, like our first container called Web01. Its IP address is 172.17.0.2. Its gateway points to this interface, 172.17. 0.1, and this interface is 192.168. 2.57. This is my interface for accessing the internet, meaning this interface can access the external network, can go out. My container. Its IP address by default is this. Its gateway is here. So here we'll have an additional rule. IP tables. T, NAT, NL. Enter. Take a look. Scroll down. Scroll down. Scroll down. Scroll down. Scroll down. Scroll down. Here you see. Here just added a rule. When you access the host machine, target access to port 80, redirect it to 172. 17.0.2's 80. Actually, in our firewall rules, it is written like this. Let me show you how this rule is written. IP tables, TNLTA, called incoming, called routing. It should be written like this. A is for append prayer, outning. P, TCP port 80. The meaning of this rule is all incoming access target for 80. This is it's like having such a firewall rule on our host machine. All incoming visits to my host machine. Target port is 80 cut. Cut is the action. Target transformation to 172. 17.0.2 as 80. This rule is like this. The complete rule is like this. This rule is automatically created for us after we create it. It automatically created such a rule for us. It says that all incoming access targeted at port 80, deport targeted at 80, is redirected to the target 172.17.0.2 port 80. That's the rule. So when you access the host machine's port 80, it's actually redirected to the container's port 80. So let's access 192.168, 2.57, and see port 80, which is just that container's port 80. So we enter this container, execute 95 bin bash. It should have been in USR lock Apache 2, the htdoc inside. You see this. Echo hello, HCIE. This is the content inside the container. Let's refresh here. Is it like this? Doesn't this have content now, right? So when you access my host machine port 80, it's redirected to 172.7.0.2. This container's port 80. My machine should be listening on port 80. I am listening on port 80. I am listening on port 80. Can my machine access the internet? Can I access the internet? Like ping, there is none. I'll talk about it later. Can it access the internet? Let's look at the rules again. Can these machines go out to the internet? Let's take a look together. There's a rule here, and SNAT rule. There's a SNAT rule here. Hold on. And SNAT rule. There should be one. 172.17.0.0. 24-bit subnet. Let me check. This is coming in. There should be a rule like this. There's a rule here. There's a rule. This rule is also my favorite rule. How is this rule written? It's written like this. There's a rule here. This rule is also how I like it. How is this rule written? It's written like this. Just now this rule, incoming visits to my port 80, redirected to its port 80. Now another rule called IP tables T, NAT A, called post routing chain, is outbound S172.17.0.0, S172.17.0.0, 24-bit subnet. That's all the source address. Source, original address, cut. Do you know what follows it? Normally it should be written like this. S192.168.257. S192.168.2.57. It should be written like this, which means all outgoing original address is this. When you go out to visit, it's converted to this address. Very simple. One is incoming, one is outgoing. Think about it. Incoming originally targeted at 257. Isn't it redirected to 172.17.row.2? Right. Targeted at visiting 2.57, redirected here. Isn't the target address changed? What about the original address? Isn't all this original place, this, when going out, isn't it converted to this address, gone out? But this machine, if there are multiple network ports, which network port can we use to get out? Also, you know how we access the internet at home? It's ADSL. And the address is a dynamic address. It's a dynamic address. Actually, today's address is different from tomorrow's. How do we solve this? Because normally, at home with my recording device, I need a fixed IP, a fixed public IP. But now I can't fix it, it's dynamic. So how do I write the rules for my recorder's release box? Do I have to change it every day? So to solve this problem, we have a feature here. It includes an IP tables, DNAT depositing, S172.7.0.0, 24 cut, called masquerade. Masquerade is called address masquerading. This term, masquerade, is called address masquerading. What does it mean? That is to say, all machines with 172.17.0, when going out, the gateway just needs to point here. Then the request will be dropped onto this machine. If the gateway doesn't drop it here, why would it come here? Why would it read my rule? Because its gateway points here, then it reads this rule. And what is address masquerading? It means no matter what your IP is here. Masquerading means, I will track this address. Today it's 257. Then when I go out, it becomes 257. If you are 258, when I go out, it becomes 258. This is called address masquerading. Called address masquerading. Masquerade. This is a method used in firewalls for dynamic IPs called masquerade. It's not the next address, it's being transformed when going out. This interface, suppose this machine has many interfaces, it can go out from any available interface. Suppose you have multiple network cards and they have different IPs. When going out, it can go out from any available interface called masquerade. Address masquerading. Now let's look. If this rule is in here now, is it there? Iptables DNAT NL. So initially, there is a rule here from 172, from 172.170.0 can masquerade out. Now I ask you, because now we are in this host, we entered and you see it's not installed anything. I'll say again, today, generally speaking, our image, its underlying operating system used to encapsulate this image. The underlying operating system usually is Debian based. Deepin is less common. Debian is more common. Usually Debian or Ubuntu are more common. And you see, if you want to install packages, how do you install them? Using what style? It doesn't have any style. How do we install packages on Debian or Ubuntu? How do we do that? Does anyone know? How are packages installed on Debian or Ubuntu? How are they installed? How is it installed? Yes, how is it installed? Apt install. For instance, we want to install NetTools. For example, before you have installed it, take a look. These commands aren't available. Right, even this command isn't available. What do we do? Apt. But before you install packages, you can't just directly install them. You see, it can't be installed. So, before installing packages, it needs to update. It needs to update first. This indicates one thing. Can this machine access the internet? It means it can. If it couldn't access the internet, you see, doesn't it also have something like YAML stuff? Doesn't it go to Debian's db.org directory, this website, to download and install software packages. Here, it's a bit slow because this is also a foreign source. We use CentOS actually. It also defaults to foreign sources. It will be slower. Okay, I'll let it run here and I'll demonstrate for everyone. So why do I use BusyBox for experiments? Because BusyBox comes pre-installed. Docker run BusyBox is a test tool. So it doesn't need to be mapped out. It doesn't even need to run in the background. I'm just testing. It calls one of its commands called SS. You see, am I in? I'm already in BitBox. Come again. You see, on this side, everything is visible. Everything on this side, it's 172, 17.0.3. Can it ping the external network? You see, is it connected? Why is it connected? It's because of that rule I just mentioned, the IP tables rule. Masquerade can go out. It can go out. Just that one, the masquerade rule. So if in the future we need to install packages here, or say we customize a Docker file, we actually all use the apt command. We all use the apt command, not the YAML command, unless it's used underneath to encapsulate the image. That one is CentOS. Then it uses YAML, first debug update, apt update first, to be able to install packages. Okay, I've already come in. You see, according to the principle, we can access the internet. See? We can access the internet. Because just now, everyone saw this diagram. You'll understand. When going out, it's transformed into this address, so it can access the internet. So just now, this rule, the second rule should be iptables, T, NAT A, post routing net, S, 172.17.0.0, 24, J, SNAT, not SNAT, because it's not fixed, Q, UBRAD, it's called simple masquerade, doing address masquerading automatically. Thus, this machine can access the internet, right? So when I come in, I will go to the external network. Okay, and my gateway, is it pointing to 172.17.0.1? My gateway is pointing to 172.17.0.1. Okay, I've talked so much, I just want to explain this issue. Let it install the package. Still installing here, still installing. I don't know if everyone understood this segment. Did you understand? Is this not similar to the principle in OpenStack of binding elastic IP addresses? It's the same, binding an elastic IP, isn't it? The elastic IP is bound to the router, all access to this address. Isn't there a rule in the router redirecting to your cloud host? When your cloud host goes out, isn't it also transformed into your just used elastic IP? Okay, is it okay? Yes, suppose there are two interfaces. One interface can connect to the internet, one interface cannot connect. What if it chooses the one that cannot? It will try all network ports. So if you have multiple network ports, it's equivalent to this address. It will exit from whichever interface it can. It will automatically make routing decisions from which interface it will exit. It will be able to exit from whichever interface. It will disguise all interfaces. Understood? Right. Can it perform address masquerading? It can track, okay? Everyone clear? Is it clear? This? Is it clear? Is it clear? That's how our network works. Is it clear? Why do I like to use BitBox? Because it's convenient for testing. You see, it almost has all the commands, all installed. First, check the routing table. First, check the routing table that's also necessary to see, the host's routing table. It will also look at the host's routing table. which network to go to, where it will go from. Definitely. Also, for example, here going to all places, 2.1 is my gateway. This is my router. If you go to another network, it goes through another port. It will automatically determine which port to go through. It will automatically track based on your routing table decision. It's possible, no problem. Okay, that's fine. Then let's continue. Okay, let's continue. Okay, now we understand. Now my second question is Docker run it, name busybox 12, and then busybox bin su. It's like this. It's inside this container. Look, inside this container, isn't this a command line? Jump to a command line. Look, the command line. Look at its command line. The command line. Okay, but it doesn't affect use. Yes. I'm saying I need to show it. I hit the wrong key again. It should be this. Enter. It's 172.17.0.4. It's actually assigned via DHCP to it. Once this container shuts down and restarts, its address might change. This address isn't fixed. It's not fixed. It's assigned via DHCP. If you turn off all the containers and then turn them on, they might get different addresses. You must remember this. So this is why we often write host tables. In our host tables, we need to write a record. So when we access, give it a fixed. Okay, next question is, what do you think? Can 172, 17.0.4 and 172, 17.0.3 communicate with each other? Can they communicate with each other? Can they communicate internally? Ask. At this place, I just launched another cloud host, right? Can these two communicate? Can they access each other? They probably can't. Why? They need to add a port. No, it's like two hosts on host only. It's like you're on like the same subnet. You need to do mapping for different subnets, right? Isn't it? You need to do mapping for different subnets, right? Look at the firewall rules. The firewall rules are, you go out. Actually, do you know? Inside this rule, they usually write something like this. For example, let me give an example. They will write a rule similar to this rule. Let me give an example. All from 192.168.122.0. All from 192.168.122.0. As long as the destination is not going to 12.0. As long as the destination is not going to 12.0. Isn't it only then that you can masquerade? See, it's similar to this rule. It's your destination. If it's going to the local subnet, it doesn't need to masquerade. It won't masquerade. So normally they can communicate, look, ping 172, 17.0.4. Do you see? They are connected to the same bridge. That bridge is actually just outside this. They are actually all connected to this Docker 0 bridge, right? This Docker 0, isn't it like a virtual switch? It is essentially a virtual switch, this Docker 0. Ultimately, all your machine's gateways point to it, and they are all connected to this one virtual switch. This virtual switch's port, isn't it somewhat similar to a VLAN interface? A VLAN interface, right? Right, it's their gateway. So you see, they are connected. They are connected. So what should the final diagram look like? It's this diagram now. Busybox, their ETH 0.0 here. You see, it will create a point-to-point connection, just like OpenStack. You see, once you create a cloud host, no, not a cloud host, a container, here it will create how is everything used. Here, you see, isn't it going to generate something like this? Isn't it related to its ID? Related to your container's ID? Aren't you deploying 3 containers here? Here are 3 container cards. Isn't it the point-to-point device? That is, how does it connect to this Docker 0? Isn't it through an interface in your container called ET0? And through this VETH, isn't this connected to your VETH? And VETH is then connected to Docker 0. This Docker 0 should be a bridge, I see. You see, one end of Docker 0, isn't it connected here? And the other end, isn't it a type device? You see, isn't Docker 0 connected to these 3 devices? Right? So here it is, a bridge device. A bridge device. After we learn OpenStack, and then come back to learn this, it feels easier to understand. So, by default, you see, they are connected. They are connected. It's the same over here. 172.177.0.3, because they both are connected to the same switch. They are connected to the same switch. So here, ET0, the gateway is here. The outside is the Docker host. The physical machine, this is its virtual switch. 172.177.0.1, and then connected above are 2 BusyBox containers, so they can communicate with each other. Okay? And this is what we call a bridge network. So when they go out, it is also through our host machine they can go out. Coming in access is also through the host machine. Coming in access through the host machine, coming in access. Okay, just got back here. Just now there was something not done. You see, this update is done now. Now installing packages, apt install net tools. Okay. After installation, you see, isn't there also this command now? Pin command is not there. It seems like you need to install a package. It automatically judges. It seems like you need to install a package called this. It will tell you your needed ping is this. Then you need to install this. This is very smart. We should have a similar feature in CentOS 8. Just you type a command. You don't know which package. It will help you find which package it is. A bit slow, huh? The ping command you wanted, it has found it for you. The ping you need is this. This also works. So you want to install a VR editor. You say, I just want to directly modify in the container with a VR editor. Is it possible? It's also possible. It's also possible. You see, if you really must, it is still possible. Need to install packages. Okay, now let's continue. Let's execute this command called docker run. Docker run / docker run dp web01. I'm just giving an example. The database and web might be more meaningful. I'm just giving an example. 8080, 880, just named Nginx. I deleted Nginx. Oh, how coincidental. Web already exists. Web 11. Okay, here comes a Web 11 machine. Web 11. Okay. Now I do this. I create a Web 12. However, here I added a statement like this called docker run dp. Originally, the database was with it at 888. I'm just making up 80. Then mainly to demonstrate this function, link Web01, not Web01. What was it just now? It's Web 11. Web 11. Add just now link Web 11. Just named Web 12, DP. And then it's NGINX. Okay. Docker exec. It. 7C2. Bin 80. Come inside here. Look here. Look here. Am I not now? You see, I'm now going to ping Web 11. There's no ping command. If there were a ping command, wouldn't I now be pinging Web 11 equal to pinging this machine? I myself am 0.4, he's 0.3. Isn't this 0.3 tracked to this, his ID and Web 11? I'm telling you, your IP address has changed. If the IP address of Web 11 just changed, I will track that its IP address has changed. So, in the future, I can always use Web 11 to access this container, even if its IP address changes. I can still track it. I can still track it. So here, the link we just talked about does just that. It uses this name to track the container. Even if the container's IP address changes, it doesn't matter. I can still track the change in the IP address. All right. It means the IP address has changed. So if I do what I just said, if you originally used an IP address to connect to it, once that address changes, wouldn't my connection fail? Right. It would still connect, but if the IP address changes, I would fail, right? Because when I connect, I need to specify this address to connect, right? So in the future, you shouldn't use this address to connect. Should you use this instead? Should you use Web 11 to connect? Do you understand? Or use this ID to connect? Use this ID to connect. It will never change. Because its ID will never change unless it is deleted. Even if you restart the container, the ID. So if you ping this ID, it's equivalent to pinging him. If not, there is no record of this in the host table. Okay? Using Web 11's name can also work, right? So this won't change. Otherwise, you would use an ID to represent it. Otherwise, using an ID to represent it. Now I've given it an additional name, right? An additional name. Use this name to connect to it. I don't know if everyone understood this. Did you understand? Use this name to connect to this container. Otherwise, the container's IP address always changes. You cannot use the IP to connect. You can't use the IP to connect. You have to use this name to connect. So even if his IP address changes, I will still track him here. I can still track him. Can I? Okay, look. Adding host records in the new container records the correspondence between DB1's host and IP, facilitates future access using the host name, even if the container restarts and the IP address changes. We will still track it. Okay, this is called a bridge network. The first one called bridge network. The second called host network. Host network. This application scenario is quite narrow. Shares the network address with the host machine. Multiple containers need to resolve port conflicts. What does that mean? Once you connect this here, if you don't connect, it's bridge. If you don't use bridge, you have to add net host just now. You find that your container's network and your host machine's network are exactly the same. Exactly the same. What does that mean? Look, Docker, run, DP 889980, net, host, name, Web 111, Apache, HTTP 2.4. He says, public support, discard using host network. You see, Docker exec, it43b. Bench, yes. It seems it wasn't allowed to run. Oh, I know now. Docker, 43b. This one doesn't need port mapping. No need for port mapping because it uses the host machine's network. So look here, this is not needed. No need for this. No need for this. Okay, let's go in. Exec IT566, bin bash. Hey, why isn't this container running? Oh, it might be conflicting with the host. What's going on? I'll run something else. Run something else. Like this. Docker run. Directly. Net host. Name. BusyBox. 001. Right, it was occupied. Can't use that one. BusyBox. Here it is, bin bash. Good. Come in and have a look. Look at this container's IP address. It was originally 172.17 something. Wow. Look. When you come in, isn't it just like the physical network? That is, this container is using the physical network. So, if you occupy port 80, why can't you use 80? Once using 80, all traffic to the host machine's port is mapped to the container's 80. At that time, your own host's 80. Will all traffic then access the host machine's 80? When you access port 80, are you accessing the host machine's 80? and not the container's 80. So this application scenario, I think, is quite rare. Quite rare. It directly uses the physical network. It treats a container as if it's on the physical level. Treat the container as if it's on the physical level. So you see, its network becomes a physical level network. Unless some security software might not allow running in a virtual machine. It needs to expose itself outside, expose its network outside, acting as a firewall, similar mechanisms. Otherwise, this application scenario is quite limited. Did everyone understand this? Directly using the physical network. If you want to access the physical level, it's equivalent to accessing this container. And if you want to run other containers on it, that wouldn't be fun. What is the IP of the container's network port then? No conversion. The container's IP is this. The container's IP is this, 2.57, number 2.57. What about the host machine then? The host machine is also this. It's like it's transparent. Your physical machine is invisible. The physical level IP is this, and your container's IP is also this. It's like your container has moved to the physical level. Many people say, now when you access it, is it your physical machine responding, or is it your container responding? On 92, 1168, 257. Oh my. This is equivalent to accessing the physical level. You see, when I'm accessing, it's not going into the container. It's accessing the physical level. So when you're in this container and you run a service, you're in the container running a service, for instance, 80, you access this port 80, it should go into this container. It doesn't need to do mapping. No need for mapping. Let's see if there are any relevant rules. I don't have similar rules. Let's see. Let's see if its listening is the same as the physical machine's listening. I see if its listening is the same as the physical machine's listening. Its listening and the physical machine's listening are the same. What is the physical machine listening to? It listens to the same things. Physical level network, 808.0.1.1.11. You see, it's the same as the physical level listening. Let me check. I'll look at this container's processes. What's different? The processes are indeed isolated. In the physical machine, it runs so many processes, but inside the container, it really is just one container, but it is isolated, just like the physical machine. It's like you originally managed the physical machine, which was not secure, but now you treat this container as a physical machine. Your services are not running on the physical machine, but inside a container. And its IP address, look, I'll ping this, 172.17.4.3. You see, it can also communicate with your other containers. Namespace. Namespace. It seems like the K8's command is needed to see the namespace. I don't know how to view namespaces in Docker. Docker seems not to know how. K8s can see. N seems to be namespace. Kubectl. N is apparently used to view namespaces. You guys can research this yourself. I also don't know where this application scenario applies, just explaining the phenomenon I've observed. But in what scenarios this network type NET would be used? NET turns the container's network into a physical level network. The only applications I can think of might be some security software, might need this. But in actual business scenarios, I haven't seen this feature used. I don't know if any colleagues have used this feature. Let's skip this. This is the host's network. You can see it's the same as our host level network. The third network type is none. This network type is similar to host only. It's a network type without an online link. It has no network address and is completely isolated. It's not called host only and still has an IP address. This one doesn't even have an IP address. What to do without an IP address? It's used for scenarios where neither access to external services nor allowing external services to access itself is needed. For instance, if today I want to run a password, I want to do an encryption algorithm, or I use a tool to do a test, do an engineering calculation, I just need to get the result out. Shouldn't it be secure? Isolated in an internal network or in a place with no network. It doesn't need to go out, nor can it come in. Host only, you might think about going out, but this one doesn't even have an IP address. Deploying a container without an IP address. Let's look at Docker run, net, null name, busybox 002, busybox, and here should add a it binge. You see, does it have no IP address? It doesn't even have a network card. It only has a local loopback address. It doesn't even have a network card. Suppose at this time, I generate a key here. Use a key generator to generate a bunch of keys, either for encryption or decryption, or for cracking passwords, something like that. It can be tested here more securely. It can't go out. It's a type with no network, okay? It doesn't need to provide services externally, nor does it need to access others of this type. This application is used for tool types. For instance, some tool types. Maybe this method is possible, okay? This is the null network type, so the default is bridge. There is also a type called custom. Okay, custom user networks can also be bridge, overlay, and other types. By default, we use bridge. So here, many people ask if they can create their own network, not using the 172 port. Is that possible? Of course, it's possible. Okay, without declaring ports, can't you just not use P? How can P not declare ports? P does declare ports. It's completely unnecessary. We talked about the function of P this morning. P, name, Weber 111, NGX, Docker, PSA. Doesn't it default to setting up a listener for you? How can it not listen? Is this where using null network could solve the problem? Okay, we originally had a network called Docker 0, created by default. Can I not use that? Is it possible? It is possible. How do you do it? It's a bit like VMware's WebNet 2, WebNet 3, WebNet 4. Similar to that, Docker, network create. Actually, it should be like this. First network first. Let's check. Do we have bridge network, host network, null network? Are these the only three types by default? Okay, let's continue. Create. You can connect a network port. Create connected to the network. Here you can connect. See, by default, it's bridge. You can connect a gateway or say the range of IPs. All are available here, whether it's IPv6 or subnet, all are possible. So here, just now, driver bridge. Actually, you don't need this sentence. You can connect a subnet. Default is bridge here, default is bridge. Okay, Docker network create. Just now, driver should be bridge, then dash 192.168.66.0/24. Then is dash gateway 192.168.66.254. Then connect the network name, my net. Look, this is how we come back. Docker network lals. We now have an extra mynet. Look here. Create a custom network. Create a custom network, just like that. Okay, how to use a custom network. How to use a custom network is Docker run DP 8090:80 net. You should choose here dash my net net. Is this using BilerBox? Otherwise, you can't see. Forget it. I'll create one first. Web 666 and then NGX. Okay, look again. You take one step at a time. You'll find you have an extra network card. Here, you have an extra one. You see a bridge called BR, Docker 0. I mentioned before, Docker 0 is just named Docker 0. Actually, it's just a bridge. BR, CTL, show. At this time, Docker 0 and this name are both bridge names. It's just called this. Actually, it's no different from Docker 0. It's just a switch. It's just a switch. You see here. Does it have 66.254? Is it the gateway? Doc. Check it out. C5, F, enter. You see his IP address. Is it 66.1? The Wild Horse Gateway. Does it have it? Okay. You come to Docker again. Run it. Directly test with BusyBox. Name, BusyBox 123. Net, mynet, BusyBox. Bin, esh, enter. You come to see. Is it 66.2? I ping 192, 168, 66.11. Is it connected? This way, have I implemented a custom network? Custom network. Okay, so just now I created a cloud host for everyone, then specified which network we are using. Custom network. Custom network. Then deploy a container. Using a custom network is fine. Okay. Ping if another bridge address is reachable. Just now someone asked. My cloud host just now to ping another person, is it reachable? I tell you it's not reachable. What to do if I want it to be reachable? Look at 456. Ping 172. 17.0.1. Ping the gateway can be reached. I ping 0.2. I see if there is, wait a moment. The gateway is reached. Docker. I look at the previous cloud host Web 01. Docker. 95. 172, 17.0.2. You come to ping. It's not reachable, right? It's not reachable, right? Not reachable. You see, he can ping the gateway. It's not reachable here. Seen. So many people say what to do about this. Now I want to make it reachable. What to do? You see, your gateway is pointing to 66.254. So just now, your questions. Very good. Is whether different subnets are reachable, not reachable. What to do? What to do? Here, you are actually running on the same host machine. Multiple different virtual switches. You see, you are connected here. You are connected here. I am connected here. I'm connected here. So, can we communicate between us? No. Can we communicate? No. Because I'm connected to different virtual switches. There's no connection between my virtual switches. There's no connection. Okay, what to do? If we want to connect, look, if we want to connect, create a container using the default bridge. Add a network card to the container. Docker network connection. DNAT 2 Web 1. Then like this. Does this cloud host now have two network cards? See here. It will have two network cards now. Not this container. This container will now have two network cards. Isn't it by default a bridge network? Later, wasn't a DNAT 2 network card added? Okay. Let's try. Let's try this. Like this. Docker. He now has only one network card. This Web01 is one network card, should be Docker. Network connection, DNAT, just now, 95, Web01. Okay, now you look again. Does he have 66.3 and another 172.17.0.2? Now he effectively has two network cards. he can obviously communicate now. The final diagram became this diagram. This is a bridge. You see, I now have a cloud host. Here, one container, not a cloud host, container. He has one network card connected here. Isn't he connected to one network card on this side? Finally, this container and the one on this side, isn't it connected? He used this network card to communicate with him. Did it show the phenomenon just now? Here, what? Directly use this phenomenon? Is it okay? Or connect it to a bridge? Yes, in any case, he still needs a network card connected to another bridge to make the connection. Do I have to make it connect okay? Do I have to make the two networks connect okay? Okay. This is what we need to learn later. Okay, let's talk about here. Let's talk about here. Did you understand the previous part now? Did you understand the previous part? Let's talk about the previous part. Okay, I think it should be manageable. Okay, here comes my question. The key question comes now. Question 1. Can containers communicate across hosts? That is, I am now on one host. If I have two hosts, you see, these physical machines called mast. If there is another physical machine, I believe I am on, when using Docker 0, another physical machine will also have Docker 0. It will also have Docker 0. And our IP addresses should all be the same, right? I believe on your host, our two hosts are connected. Our two physical machines are connected. We are in the same classroom. We are connected. But can our two containers communicate? Can the containers on my two host machines communicate? Not just different containers on my two host machines within the same subnet. Do you think they can communicate? Can they communicate? For network RT, because of the cloud platform, can containers communicate across hosts? Do you think it's feasible? It's possible. How do they communicate? How do they communicate? And it's very likely that both sides have the same subnet. Many say just make it different. Customize the network to be different. Is it feasible? Also, deal with routing. Okay, this is what we need to focus on next. That's how it is. Port mapping, still port mapping. Where are you taking this? My two aren't communicating. If it goes through port mapping, does it go out to the internet? That and accessing from other machines. Isn't that indistinguishable? What I'm hoping for is internal container communication. If it's mapped through the outside to ports 80 and 3306, then doesn't that mean I don't have two containers? Just like accessing from Windows, isn't it the same concept? What I am now asking for is for virtual machines on two host machines to communicate, not through mapping to access. That would defeat the purpose. Then it wouldn't be communication anymore. Okay? So I'm telling you, by default, they cannot communicate. By default, they cannot communicate. What should we do? We need a third-party solution. Popular third-party solutions now include Fly. The first one, Calico, Flannel. Currently, Docker itself doesn't offer such solutions. They all require third-party solutions to implement. Currently popular, Flannel, Calico. These are Kubernetes components. They can also be used for Docker container communication. So Kubernetes uses Flannel or Calico as its solution for cross-host container communication. It is a third-party plugin. Flannel, Calico, do you have to do it in Docker? Can you? Yes. Yes. I've written a document. Flannel, FL. Just a moment. Yes. This is an experimental manual I wrote. In this scenario. He also uses etcd for the database just like in OpenStack. There's also a key volume configuration database called etcd. The left side is host 1. The right side is host 2. The flannel network connects them in the middle. Look, this side is 10.240. This side is 10.217.0. The host machine is 56.104. This side is 56.105. They use different flannel networks. 10.240, 10.2, 17.0. The IP addresses are also different. Okay, so this one, the etcd database host is 0.203, provides Docker network. This is 0.208, 2 Docker hosts. Okay, we configure etcd on this Docker network host. Download the flannel package from GitHub and unzip the etcd package. Copy this package to your root directory to unzip. I've written it very clearly, but today I will not demonstrate. This is a network plugin used later in Kubernetes. Then copy it over here. Docker vol1 config. Then it got another 172.16.5.1. This is its subnet. We're on another host. Look, I deploy a cloud host through this network. It gets 172.16.5.3. I do the same thing on Docker O2. Do the same thing. We get a 172.16.9.2. Then let's see. Look, I ping 172.16.5.3 from here, and it's reachable. Look, I'm pinging 172.16.5.3 from 172.16.9.2. We can ping across hosts to another container's network. This is a plugin solution from Flannel. Look here. It's all done through etcd for discovery. A discovery here. So today, I'm not demonstrating. I'll send everyone this experimental manual. All right. I'll send everyone this experimental manual I wrote back then. You see, we also have a detailed introduction here. Look here. I'm sending these 2 documents to everyone. I'll also throw in this software package for everyone. I'll send everyone the needed software packages. You don't need to download anymore. Take a look. Cross-host communication all requires third-party plugins, including Kubernetes. Kubernetes also works this way. Across hosts, there are solutions. Can't steal it. These software packages are all here. I'm also sending these 2 software packages to everyone. They are all here. Downloaded already. Okay, I'll show you the network solution in Kubernetes. Kubernetes is not this complicated. It can be deployed in one step. It's already written for you. Here is the Kubernetes installation. Which includes adding Kubernetes resources, must install here. Also, the Flannel network. Look here. This is the Kubernetes installation method. Here it mentions installing a network plugin. See it or not? Flannel network plugin. It actually executes one that's already written. You can download the Kubernetes Flannel YAML file online. After downloading this file, use kubectl apply F to apply this file. It will automatically help you deploy the cross-communication network. So, we don't need to deploy manually. In Docker, we deploy manually, but in Kubernetes, it can be deployed directly. Just install a network plugin. So Kubernetes cross-host communication also uses this solution. Okay. It also uses this solution. It has a YAML file already written. You just run the YAML and it automatically sets it up for you. Okay. Take a look at this. So Docker cross-host uses this Flannel network specific configuration. I've written an experimental manual for everyone. Okay. So what we've been discussing is on a single machine. It's somewhat similar to what VMware Workstation. You are currently running a standalone version of VMware Workstation. Its network is also standalone. Now it has become a distributed network, which allows cross-host communication between containers. Can this PPT be shared? Yes. I'll put this PPT on Baidu NetDisk later. Okay, no problem. Is that okay? Is this segment okay? Okay? Everyone, understand this. How does cross-network communication work? Everyone, understand this. Cross-host. Cross-host. So this afternoon, we also spent about an hour introducing everyone to the relevant concepts of this network. You can search this, for example, Kubernetes network plugins, and you can find these. Look at some of the more popular solutions now. Container Network Interface, CNI. Then others can develop their own plugins based on this CNI standard and can also achieve compatibility. Then here are two quite mainstream network solutions. In between is also a tunnel network that is VXLAN technology. NAT is definitely not good. Just let them communicate directly. Isn't direct VXLAN communication good? Doing NAT reduces efficiency. Okay, that's about all we'll say about Docker networking. So today we've discussed storage, talked about networking, right? We've talked about Docker storage and networking. So everyone should have a general understanding of the whole Docker principle now. Many people say that since you need this, why still learn Docker then? It's because at the level of Kubernetes, its underlying layer is still running Docker containers. Kubernetes is just to make managing and scheduling containers more convenient, but the underlying technology still uses Docker. So a foundation in Docker is definitely still needed. We often troubleshoot. In fact, we go into the Docker container to troubleshoot in the underlying Docker. It's a bit like our OpenStack. We must first learn the open source KVM. With KVM, we then learn OpenStack to schedule KVM virtual machines. When troubleshooting, we still need to understand some troubleshooting methods for KVM. It's the same principle. Yes, so the relationship between Kubernetes and Docker is just like the relationship between OpenStack and KVM. All right. Okay, shall we take a break? After the break, we'll learn how to customize our container images, somewhat similar to customizing our OpenStack glance images. How to customize glance images. How we today customize Docker container images. This is also a focus of our exam. Our HCIE 3.0 exam focuses on teaching you to customize images. You have to write the code yourself to achieve this. Soon I'll teach you how to write the code to do this. And during the exam, the requirement is that the entire code does not exceed 10 lines. Your container image should not exceed 500 MB. It's about making it as lean as possible. Okay, shall we take a break? Let's take a break.